Welcome to Geometrix Galaxy. Good morning students. Today we will see about real numbers and their decimal expansion. We all know that real numbers are the combination of rational and irrational numbers. So now let us try to understand the decimal expansion of rational and irrational numbers. So the decimal expansion of real numbers can be classified into three types. Let us see what are they. They are terminating decimals, non-terminating repeating decimals, non-terminating non-repeating decimals. Now let us see what is terminating decimals. The decimal expansion terminates or ends after finite number of digits. Example 1 by 2. 1 by 2 is equal to 0.5. 3 by 4 0.75. 1 by 8 0.125. Here all the decimal part comes to an end. So terminating decimals are rational numbers. So now let us see what is non-terminating decimals. Here the decimal expansion does not come to an end and it has an infinite number of digits. But this is further classified into two categories, that is non-terminating repeating decimals and non-terminating non-repeating decimals. We will see first non-terminating and repeating decimals. The decimal expansion will have repeated numbers. See the example. So 1.454545. So the number 45 is getting repeated without coming to an end. The next case 0.333. The number 3 gets repeated in the decimal part. The next example is 0.127. 127, 127. The number 127 gets repeated. Okay. So in the first case only two numbers gets repeated. In the second case one number is getting repeated. So any number of digits can get repeated. You have to keep this in mind. Now non-terminating repeating decimals are rational numbers. You have to note this point, students. Next, let us see what is non-terminating and non-repeating decimals. The numbers after the decimal point is non-terminating and the decimal numbers are not repeating. Okay, so if you see the example 2.347651, then the numbers are not coming to an end, but it is not getting repeated just like the previous case. This 0.30730073 00073. If you take this, it is in a form of a pattern. So 307, the first three numbers, the next number is 3007. It is not getting repeated as 307, 307. You see there is a pattern. The number of zeros is increased in between this 3 and 7. So it will not come under repeating decimals. So we create a pattern. Here the next example is 0.131331 Here also a pattern is created. So this will also considered as non-repeating decimals. So now note, non-terminating, non-repeating numbers are irrational numbers. Now look at this flowchart. Okay, decimals are classified as terminating and non-terminating decimals. Non-terminating are classified as non-terminating recurring decimals, non-terminating non-recurring decimals. Now we just now studied terminating decimals and recurring decimals are rational numbers. Non-terminating decimals and non-recurring decimals are irrational numbers. we will do example 5 of your NCERT textbook. Find the decimal expansion of 10 by 3. So this is the first subdivision. As usual, we are going to divide 10 by 3 using long division method. You all know 3 3s are 9. So after that the remainder is 1. 1 is smaller than 3. So put a point and proceed. So again you are going to get 3 3s are 9 and the remainder is 1. The same procedure will be followed. Okay. So but it will never come to an end. So 10 by 3 is equal to 3.333 etc. So this is an example for non-terminating repeating decimals. So repeating remainders, if you see the remainders, it is continuously we are getting 1. Okay. So we will see what is the second subdivision. So we are going to do the decimal expansion for 7 by 8. Same procedure you have to follow. That is 7 should be divided by 8. 7 is smaller than 8. So you put a point and add 1 0. So it becomes 70. Now 8 8s are 64. So the remainder is 6. Add 1 0. 7 8s are 56. Now the remainder is 4. Add 1 0. 40. 8 5s are 40. Now the remainder is 0. So the division comes to an end. 7 by 8 is equal to 0.875. This is an example for terminating decimals. Okay, the remainders are 640. If we get the remainder 0, then the division comes to an end. Okay. Now, this is the third subdivision of example 5. Find the decimal expansion of 1 by 7. As we did in the previous two cases, we have to do the normal division. Just we have to divide 1 by 7. So we are getting the answer as 0.142857. But it is not coming to an end. Okay. So it is ending, the remainder is 1. So again we are going to get the same set of numbers 142857. Okay. So 6 digits are getting repeated. And it is a non-terminating. So it's a good example for non-terminating repeating decimals. If you see the remainders, that is also getting repeated. So if the remainders repeat, then the quotient will also repeat. Example 6. Show that 3.142678 is a rational number. In other words, express 3.142678 in the form P by Q, where P and Q are integers and Q not equal to 0. This is very simple, students. Just we need to write the decimal number in the form of fraction. That is 3.142678 can be written as 3142678 divided by 1000000. So if you see how many digits are there after decimal point, there are 6 digits. So we add 6 zeros in the denominator. We also know 0.1 is nothing but 1 by 10. The same strategy we are using here. So we have written the decimal number in the form of P by Q. Okay. Hence it is a rational number. That's all. Example 7. Show that 0.333 etc. is equal to 0.3 bar can be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0. Let us see how to do this. Let x is equal to 0.3 bar. Okay. We can also write this as x is equal to 0.333 etc. Next, let us consider this equation as 1. Now we have to multiply this equation 1 by 10 on both sides. So we will get 10x is equal to 3.333 and this is equation 2. Now we have to subtract equation 1 from 2. So we will get 9x is equal to 3. The decimal part is same, so it will become 0. Only the whole number 3 will be your answer for 9x. So x is equal to 3 by 9. If you simplify this, you will get x is equal to 1 by 3. Now let us see example 8. Show that 1.272727 etc. is equal to 1.27 bar can be expressed in the form of p by q, where p and q are integers and q not equal to 0. This is same as example 7. Let us take x as 1.272727 etc. and let this be the equation 1. Now we need to multiply this equation by 100. But you should have a question, why we are multiplying this equation by 100? Okay, this is because we are having 2 digits repeating. Okay, 2, 7. In the previous question we had only 3. 1 digit only was repeating. Here there are 2 digits repeating. Okay, so this becomes 100x is equal to 127.272727. If you see the decimal part, in both the case it is same. This is equation 2. Now we have to subtract equation 1 from equation 2. So if we subtract, we will get 99x is equal to 126. The decimal part gets vanished. So x is equal to 126 by 99. If I simplify this, I'll get x is equal to 14 by 11. Example 9. Show that 0.2353535 etc. is equal to 0.235 bar can be expressed in the form of p by q, where p and q are integers and q not equal to 0. The solution is, first take x is equal to 0.2353535 etc. be the equation 1. Now you have to notice the bar is only for 35, not for 2. So 2 does not repeat, but the block 35 will repeat. Now our next step is to multiply the first equation by 10 and 1000 to get the second and third equations. Okay, now multiply the first equation by 10. You will get 10x is equal to 2.353535 etc. This is equation 2. Next we are going to multiply the first equation by 1000. So we will get 1000x is equal to 235.353535 etc. This is our third equation. Now you should have one question, why should we multiply by 10 and 1000? So this is to get the same decimal part on both the equations. Now another question, why should we get the same decimal part? To get the decimal part 0. Okay, so now we are going to subtract equation 2 from equation 3. So what is our equation 3? 1000x is equal to 235.353535 etc. And what is our second equation? 10x is equal to 2.353535. Now you do the subtraction. Therefore 990x is equal to 233. X is equal to 233 by 990. Example 10. Find an irrational number between 1 by 7 and 2 by 7. So we need to find the value of 1 by 7 and 2 by 7 to find the answer. 1 by 7 is equal to 0.142857 etc. We have already found the answer for 1 by 7 in example 5. Okay, you can refer that, or you can find the value by doing the long division. If you know the value of 1 by 7, it is very easy to find the value of 2 by 7. We know that 2 by 7 is equal to 2 into 1 by 7. So replace 1 by 7 by its decimal value. So 2 by 7 is equal to 2 into 0.142857. So if I multiply by 2, I will get 0.285714. So finding a irrational number between 1 by 7 and 2 by 7 is nothing but we need to write a decimal value which is non-terminating and non-recurring. Okay, take the values of 1 by 7 and 2 by 7. Now there are infinitely many irrational numbers between these two numbers. Okay, I have given you 4 examples even though they have asked only one. Okay, see here students. Okay, check this. All the numbers are more than 0.142857 and less than 0.285714. So I have used a pattern. I already taught you how to write numbers in a pattern. So use that logic and do and give any irrational number. Okay, now that's all with these examples. In the next video I will teach you exercise 1.3. If you find Geometrix Galaxy helpful, consider subscribing to my channel. And please don't hesitate to recommend this channel to your friends. Thanks for watching.